Welcome back to the series on multipart epoxies. One of the common topics and questions we keep getting, both Shane and I, and in the Q&As with Mark Lindsay or in other places, is this whole concept of what do we mean by overlap of the vectors and why is that important? I think many people understand basically why we're saying that, but sometimes it's hard to visualize. So I thought I'd do a quick video. We'll see how quick it is, on the concept of overlaps and using vBits and what we're talking about when we're setting up our vectors to do our multicolor epoxy pours. And if not done properly, then the colors won't be as we expect and we could have problems. So let me go over some vCaarve basics first, and then we'll talk about how that impacts how we design our multicolor epoxy vectors. So let's get started with that. As a review, let's talk about how a vCaarve bit actually works. Let me bring up on the screen a picture of a vBit real quickly. These are diagrams of a 15 degree and a 30 degree vBit. These I actually got from the Tools Today website. So let's look at the profile cuts of a 15 degree vBit. The typical bits we use in our epoxy inlays are 15 and 30 degree vBits. So we'll look at these two. As you can see, the angle here is 15 degrees and 30 degrees. And let's talk about how this works. And then they've got, of course, the tip size. But what we're focused on is this angle and how deep the bit will go. When you set up a vCaarve Toolpath, the way it works is, depending on how big or how wide the area, I should say, that you're actually going to vCaarve, depends how deep this goes. So, and I'm going to demonstrate that here in a minute. So just kind of pay attention to this concept if you don't already know it, and then we're going to demonstrate it in an actual visual in just a second. So if the area that you're vCarving is 0.02 inches wide, then what will happen is this vBit will go down to the point where 0.02 inches is covered by this width of the bit. So you can see in a 30 degree vBit, since it's wider, it's not going to go as deep as a 15 degree vBit. So a 15 degree vBit would go actually deeper to get to the 0.02. If we increase the width of the area being carved to 0.04, then the 15 degree bit will go even deeper and deeper, and the 30 degree vBit will still go deeper, but it's not going to go as deep as the 15 degree vBit up until a certain point. Once you get to the point where the vBit, meaning the V section here and here, once you get to that point that it can no longer cover the actual width of the line, it will actually keep driving down in until there's a hole. It will drive all the way to the bottom. So that's how a vCarving is set up. That is the purpose for a flat depth. You do not need to have a flat depth in setting up your vCarving tool bits if the bit, meaning the V, will go down to the depth you want it. But if that width is too wide, then you need to put a flat depth so you can stop it from going too deep in the material. So the only purpose of a flat depth is to stop the bit from going too deep. It doesn't guarantee that the bit will go to the depth you want it. As we stated, the bit will only go to the depth until it covers the area of the line. With those fundamental vCarving concepts in mind, let's do a couple demos and see how well we can illustrate this. What I've done is set up what I'll call a test card, and I'm going to focus on two types of vBits, one a 30 degree vBit, the other a 15 degree vBit, and watch how they actually carve a given vector or set of vectors. So the test card I set up is, this is a 0.02 inch rectangle, as you can see up here. This is a 0.04 inch rectangle. This is a 0.06 inch rectangle, 0.08, 0.1, and 0.12. So many times people have asked, well, what's the thinnest vector you can actually carve? This should help with that concept also, and why you might have to provide special attention in some cases. And yes, there is a certain vector that's too small for you to actually get the epoxy in and have it stay there through the whole process. And hopefully this will demonstrate that also. So let's take a look at what we've got here. I've got this test card. I've set it up such that we have each of these various widths of vectors, and hopefully this is going to show as well on the screen as it did in a couple practices here. Let's take a look. And so the first thing I want to do is I want to preview what each of these look like in the actual material. So I'm going to the 3D view, and in the 3D view, the first thing I'm going to do is I'm going to actually carve the 30-degree bit. So I've set up a toolpath where we're carving a 30-degree vBit path. If you want to see what that looks like, it's a 30-degree, start at 0, flat depth of 0.125, and we're using this bit right here. And so we'll go ahead, and I've already calculated it, so I don't need to recalculate it. And we're going to preview this now. Preview the visible toolpath. That means the one that's checked. And as you can see, the vBit is going through and cutting the material. I want to point out one thing before I move on to the 15-degree vBit. So let's take a quick look. Look down. Let's see if it shows up. Yep, look down in the lower right-hand corner. And notice how this vBit comes down to a V and then flattens out and then comes up. That's the flat depth that we put in at 0.125. And if you look down at the bottom, it's hard because of the pixels, but if I get it just in the right location, you'll see that's 0.125 inches. This would be 0.125 inches, and this would be 0.125 inches, because you can see it's still a little flat there. But when you get here now, because of the angle of the vBit, the 30 degree, it's not getting to 0.125 inches. It's only getting to about 0.10, 0.11. Hard to really see because, like I said, of the nature of the pixels, it's hard to get right on it. Also, if you go to this next one, which is the 0.04 line, you can see we're getting pretty shallow, 0.05, 0.05, 0.055. And if you go to the 0.02 line, you can see it's not really making much of a V cut in there at all. So that means the epoxy is only getting 0.02 deep. Now let's go take a look at the 15-degree bit and what that does. Now what would our expectation be? Our expectation would be that the 15-degree vBit should go deeper than the 30-degree vBit, and the 15-degree vBits will be placed right in these areas. Now, would we expect it to go deeper in this area and this area? Let's take a look at the setup. We would not, because it's going to only go to 0.125, and then it's going to stop going deep and just go across. But when you get into these areas, we do expect it to be a little deeper than what the 30-degree is. So let's take a look at that. So as expected, the 15-degree, that's this one here, went deeper than the 30-degree in each of these cases until we reach the point that it's going to the 0.125 depth. And it will create its carve such that the bit goes down deep enough so that this vector line or vector area here and here, here and here, these are actually the same. It's kind of an optical illusion you're getting because of how this thing is twisted, so don't get distracted by that. It's an optical illusion about how I twist it to be able to see the toolpath. The actual top vector, don't pay attention to the bottom, the actual top part of the vector was the 0.12, and it will stay 0.12, and this will stay 0.12, regardless of which bit you're using. But look at the difference in the profile with the 15-degree, and I'm using the bigger area over here. The 15-degree goes almost straight down, comparatively speaking, to the 30-degree. That's also going to become important when we start having the overlap discussion in a couple minutes. So that demonstrates, I think in a pretty good way, the difference of using a different angled vBit. If I were to use, say, a 90-degree vBit, it may even just barely put a scratch here. Let's go to now what happens if you only have that shallow of a resin pour. I'm looking at the 0.02 line, and I'm looking at the 30-degree. Even the 15-degree only goes down 0.05, which is a lot better. So let's take a look at the milling process. The milling process is using a flattening bit, and I've got here a cut depth of 0.02, which is about a half a mil. So it's real easy to take off a half mil or even sand it off if we're not careful. Let's take a look at what happens to the resin we would have poured in each of these areas. So I want you to take a look at, as close as you can, I'm not sure how good it will appear on camera, the milling process is going to come down and the bit's going to start milling across here down 0.02 inches. And I want you to take a look particularly close at these last two, but also these, to see what happens to the resin that would have been in there. You can see this line shows what's going to happen. Take a look real quickly. You may or may not have any of this resin left if this was the size of your vector that you were filling. And you're going to have very little over here. Let's demonstrate. I'm going to take it up here, and I'm going to go back and I'm going to re-preview. Since these are the ones that we're most focused on, I'm going to try to use blowing up this screen. Use this preview here to show what I'm talking about. Okay, you can see how much more we have here, but still not very much. 0.02 line. If you get down to 0.02, you're really risking, if you have to do any sanding or polishing, of losing that epoxy color. 0.04 is about the lowest you can go and still have something to work with, but you're really iffy when you do that. Again, this is a 15 degree, this is 30 degree, 15 degree, 30 degree vBit. And let's do one more mill path real quick, and hopefully it won't crash on us this time. I'm not going to get into doing it with these speed controls. I'll just do the preview visible path and see what it does. You can see the vBit moving along here. I mean, not the vBit, the clearance bit, the milling bit. Look at how it's taking the material off. Hopefully you're following that bit as it goes along. That's what this is illustrating. I think it's a good visual of what's happening as each of these resins are getting pulled away. And that'll become really important when I discuss the overlap function. So this is just basic vBit function and how it's going to impact your overlap concept, which I'm going to demonstrate in a minute. So you can see how these resin, the amount of resin is slowly getting carved away by the milling process. And I want you to be particularly aware of this one right here, which is the 0.02. You can see how much a 0.04 went away. Let's look at the 0.02 vector width and a 30 degree vBit when it comes through here. Once again, this is the milling process, and this is what's going to happen as you start to mill it off. And then, of course, you're going to sand and polish it from there. And this will demonstrate what happens. And in fact, in my 3-color epoxy there, this is what happened to me, is I didn't take this into enough consideration, and you'll see that in a later video. In summary of this section, what I was trying to demonstrate is how deep your vBit will go in a vCarving toolpath, and how that's limited about how deep it goes based on the angle of the tool. So the 15 degree vBits go deeper than the 30. In a multicolor epoxy inlay, your resin is, the color of your resin is in that path right there. And you have to mill it down at least flat. And it's hard to get it exactly flat. You'll probably be 0.2 to 0.5 mils below that, and then you take that and surface it down. I'd only milled a half a mil there, 0.02. That's kind of low. You're probably going to get closer to 1 mil by the time you're done. Then if you sand it, you're going to take away more material. So that's the point of this. You can see you may not have any epoxy left if you're not having a wide enough vector. So when you're setting up your vectors for carving, you need to pay attention to the width of those vectors. Now, one way you can actually deepen this, if I reset this real quickly, I will reset, would be, let's go to a 30 degree vBit. If I were to set a starting point of, say, 0.02, that means the whole cut is going to start at 0.02, and I calculate that now, and I preview that toolpath. I think you can see it's deeper because it's already starting at 0.02. And if I do a mill, it would have more of it left. So that's one way to get a deeper toolpath. With that said, now let's move on to the overlap discussion and how this all impacts overlap and what you need to look at. At this point, I'd like to demonstrate the concept of overlap vectors. Let me show you what I have. I have another test card here now, and I've taken those same vectors, 0.02, 0.04, 0.06, 0.08, 0.1, and 0.12, and I've actually laid them right next to each other. So this would be no overlap. The vectors, the art vectors, are right next to each other with no overlap between the two. And the same thing over here. So this is my 15-degree vBit example. This is my 30-degree vBit example. So this is the 30-degree over here. This is a 15-degree. So let me demonstrate what that looks like. So I'm going to go ahead and put the vBits carved, preview their path. So let's take a look at these profiles. Remember, this was a 15-degree vBit on the left side and the 30-degree vBit on the right side. And if you look at the vectors, you can see that in between the vectors is blank spots. So in between that is either wood if you've had no resin fill, or resin if you've had a resin fill. So one of the things that Shane talks about, and we've talked about before, is filling a pocket full of a primary color, be it black, yellow, white, or a clear resin that you will see. If you don't do that, then you just have wood that you're carving into. So depending on what you've got, whether you've got wood, these little mountain peaks, I'll call them, are either wood or they're another color resin, depending on whether you're carving into resin. So as you can see, it comes to a peak. So let's say this was a yellow color and an orange color, and this was wood underneath, or yellow and black, or what doesn't matter. That means that anything I take off of this cut, if there's no overlap, is going to actually expose whatever is underneath there, whatever that is, if it's wood or if it's another epoxy. So you want to have nice crisp lines, you want to be able to overlap. And let me demonstrate by taking and milling it off. So that's the same over here on the 30-degree process. You can see that that's even more dramatic on the 30-degree, how much further the material comes up. So let me mill the 30-degree, which is over here on the right. And I'm going to take 0.02 inches as part of the milling process. The other thing I want to point out is you can see these peaks are all at the same level of the 0 point. So I'm going to mill that down. So if you take a look now, what do you see? You see these peaks have been shaved off. What that means is you can now see whatever that peak is, if that's wood or a different color epoxy. So you're now no longer having a nice crisp line between those two colors, because whatever is in that area between those two colors, whether it's wood or clear or a different epoxy, is now visible. So you've no longer got your nice definition between your epoxy colors. Let's do the 15-degree. In the 15-degree, you see you have these mountain peaks, and now you have those. So let's see if I can turn it down and see if that helps with it at all. It's hard to get the good pixels to show up just right, but hopefully you can see that we've got this flat area here, which is pretty large, and this flat area here that is either wood sticking through if you've not backfilled with the resin of some sort, such as a blue color, a yellow color, black color, whatever your primary color is, or you've got wood if you're just carving each individual vector into wood. I'm not sure how you're going to do it. We typically pour the primary colors so that if this disappears, then if the other color starts to disappear, you get back the primary color. But that's the concept of overlap, is making sure that you don't get these unknowns, I'll call it, layers between the colors. So let's go over to one where we have overlap. Now we're on a different screen I've changed over to, and what I'd like to point out is I still have the 15-degree vBit for carving over here and the 30-degree vBit for carving over here. But you'll notice the vectors are overlapped. So I've overlapped these vectors not by a significant amount, but by 0.005. 0.005. And I want to show you how much that little overlap actually helps keep your color definitions where you want them to be. So let's take a look at this and go back to the 3D view now. We've got the 3D view, and let me change it to that. And we're going to do our 15 and our 30-degree milling path, preview visible. Now watch the way this is milling. And look at how the actual peak of each of these is down below the actual surface of the material. So the peak on your vBit is above the actual surface of the material. So as you are, let's say you had this one carved, and then you carve this one, you're actually coming a bit over the other one, and your chance of getting more of this peak is lessened. Let's see if I can show. I want to point out how these peaks are actually below the upper. So when you start to mill, your impact on milling of interfering with how these vectors look is going to be reduced, and your chance of getting this underlying color is going to be reduced. I hope this is making sense. Now let me mill. Let's go with the 30 for now, and then we'll do the 15. And you can see with the 15, with the 0.005, there is virtually no flat spot on top. With the 30 degree, again, this is superimposed, so I'm not sure how clear it is. There's a little bit of a flat spot, which meant that the underlying material could be seen, but not nearly as much. So that's the advantage of the overlaps. When you hear Shane or I talk about overlapping vectors between colors, it's that concept of making sure that what gets exposed as you carve the material is what you want exposed, and trying to keep nice crisp lines. Well, it's been a pleasure sharing this information with you today. We've received many questions in our Q&A sessions and other environments about what Shane means when he's talking about making sure he has overlapping vectors between two different colors, or vectors inside of multi-layer epoxy inlay. I went through the basic concepts of what how a vBit carves, and then I went through why you have to have the overlapping vectors to try to avoid having material that you don't want exposed, or to ensure that the width or shape of a vector is what you had planned after the milling process. I hope it was helpful to some of you, and it should fill in the gaps for what we mean by overlapping vectors. But furthermore, you need to learn how to apply that concept now in reality when you're designing a multicolor inlay. I know that Shane and Mark Lindsay are both working on videos where they're going to demonstrate the process of putting those overlapping vectors into their design. I was just speaking with Shane a little while ago today, and he's got a board that he's been working on, and he's very close to being able to demonstrate on that specific inlay how he overlapped the vectors and talk through that process. So hopefully this information will give you enough background that when he talks about that, it makes sense to you. I also know that Mark Lindsay has a video coming out tomorrow, I believe it is, on his pirate vectors. So I think that this background and watching them will give you a lot more insight and information on what you might be able to do for your own projects, or at least I hope it does. It's been a pleasure sharing this information with you, and if you like it, a thumbs up would be really appreciated. Also, I appreciate comments. If there's something you would have liked to see me do differently or better, I'm open for that. I also would appreciate it if you would share this video with others that might be interested in this type of content. If you feel so inclined and subscribe, you'll be able to get notifications of future content. Have a wonderful day. Have a wonderful life. Until we meet again. Thank you.